In this video, we're going to go over an AP Physics-y type of problem related with 2D kinematics. So in this problem, we have a small dart is launched from the ground at 30 degrees above the horizontal at an initial speed of 10 meters per second. At the highest point in its path, it hits a block. So in this problem, you have to find what is the speed of the dart right before it hits the block, and to find the distance between the launch point and the point it hits the block. So I'm going to quick kind of have a diagram of this problem and how to set it up, and then we'll tackle 1 and 2. So in this problem, we have a dart, and it is launched from the ground at 30 degrees above the horizontal at 10 meters per second. Now, normally the dart would go up, kind of like this, and then it would come back down. So it kind of go up, here's maybe approximately its highest point, and then come back down. Now, in this case, the dart hits a block at this point. And so the first part of this problem is to find the speed of the dart right before it hits this block. So kind of basically at the highest point in this path. And the second part of the problem is to find this distance here from when it's launched to when it hits the dart. So this distance here. So using projectile motion, pause this video and tackle part 1 and part 2. Okay, so now we're gonna first go over part 1. What is the speed of the dart right before it hits the block? So if you'll remember, projectile motion, we kind of have motion in 2 directions, in the x and y. And so in the x, so this dart has an initial velocity of 10 meters per second. And so some of that velocity is in the x direction, vx. And some of that initial velocity is in the y direction. I'm going to call that vxi and vyi. Now we know that this angle is 30 degrees. So we can find these two values just using trig. So like pretend you have a triangle with some hypotenuse that you know is 10 and 30. And your job is to find the two sides of the triangle. Kind of the same concept. So here, our vxi will be 10 cosine of 30. It's just, and then our vy initial will be 10 sine of 30. So if you do that in your calculator, you will get that vxi is about 8.66 meters per second. And sorry, you'll get that vy in the initial direction will be 5 meters per second. Okay, so going back to the x and y table, in the x direction, so we know our vx is 8.66 meters per second. Now this, the horizontal velocity in this motion stays constant at 8.66 meters per second for this entire motion here. And that's because acceleration is 0. So we know that the distance that the dart will travel will simply be Vxi times time. Now, another thing that we know is at this highest point, so the initial velocity in the y direction starts off at 5. And as the dart flies, this velocity in the y direction will slowly start to decrease until it reaches 0 at this point. At this highest point, the dart for a moment, all its velocity is in this direction. There's no vertical velocity at this point. Then, if there had been no block, the dart will continue to fall to the ground and the vertical velocity would start to increase in the negative direction. So at this point, there is our Vy is 0. And so the answer to this, what is the speed of the dart right before it hits the block? There is no vertical component. And so all of the speed of the dart is in this motion. And this, the horizontal velocity, stays constant. So the speed of the dart right before it hits the block will be 8.66 meters per second. Now the next part is to find the distance between the launch point and the point it hits the block. So this distance here, d. Now I know that my velocity in the x direction is 8.66, but the next thing I need to find is the time it takes from here to here to get my distance. So let's list all the things we know of in the y direction. So I know that my Vy initial is 5 meters per second. I know that my Vy final is 0 meters per second. And I know that my acceleration is negative 9.8 meters per second squared. So I can use my kinematics equation, V final equals V initial plus acceleration times time. So this here is 0. So I have negative 5, I brought this over to the other side, equals negative 9.8 times time. So time will equal 5 divided by 9.8, which is about 0.51 seconds. So now I know the time it takes from the dart from this point to right before it hits the block takes about 0.51 seconds. So now I can go here, so the distance that it traveled before it hits the block will be 8.66 meters per second times 0.51 seconds, and that will get us to be 4.42 meters. 4.42 meters. And so that is the distance between the launch point and the point it hits the block. Okay, thanks for watching.